Hello students, welcome to my channel Elite Maths class. Today I am here with the third video of the determinant. That is, I am now actually discussing the theoretical parts only. This is my third video. So if you are watching first time, you first go through the first two videos whose links are given in the description box. And today's topic is minors and cofactors and value of a determinant by cofactors. Already two methods of finding value of a determinant are discussed. One is Laplace expansion method and another one is, which is also the shortcut method, very easily you can find the value, which is called search method. These two methods are already discussed. Today we will see what is minor, what is cofactor, and how to find the value of a determinant using cofactors. This is nothing but the alternative representation of the Laplace expansion method. So one by one, let us see first what is minors, and all of these are correlated actually. That is, cofactors are defined by minors, and this is actually using cofactors. So all the three are connected. The first thing we have to know is minor of a determinant. What are minors? For example, I have taken a 3/3 determinant here. This is the general form, already discussed in my previous videos. You go through the links. This is the standard or general form of a 3/3 determinant. Now what is minor? So before that, how many elements are there? There are 9 elements in a determinant. Every element having its own minor. That is, as there are 9 elements, every element having their minors, so there will be 9 minors. So in general, let us take Mij be the minor of Aij. Ij varies from 1 to 3 as it is of order 3. So the values of I will be 1 to 3 and values of J will be 1 to 3. That is what M11 represent. M11 represent, it is minor of A11. What say M32? M32 will be minor of A32. This is the notation how the minors are denoted. Now see the definition of minor. The minor Mij of Aij is the value of a determinant, value of a 2/2 determinant. See here, obtained by deleting ith row and jth column from del. That is the from given determinant. So what is minor? So I am explaining here. So we have to find the minor of A22. That is M22 of A22. By this definition, what is the minor? It is the value of a 2/2 determinant obtained from del by deleting ith row, jth column. So here number of row is 2 and number of column is 2. That is, this is the second row, this is the second column. So we have to delete these 2 row and column. Then what remains? Then see, these 4 elements remains. So what will be the value of M22? So M22 will be, by deleting second row, second column, we will get a 2/2 determinant, and these will be A11, A13, A31, A33. Now what will be the value? This is by simply expansion of this determinant, already discussed. This one will be this into this, A11, A33 minus this into this, A31, A13. This is the, whatever be the value is the minor of A22. Clear? So this is the minor process of finding minors and definition of minors. Later on I will explain this by an example. Now let us see what is cofactors. For this, first we have to know the minors. This is already known, just I explained and gave the definition. Now how to find cofactors, or what is cofactors? In my previous videos I discussed the rule of sign of a 3/3 determinant. These are the sign of positions, plus, minus, plus. Now what is cofactors? Minors already known. Let Cij, also denoted by Aij, be the cofactor of Aij in del and obviously here ij 1 2 3, ij having 3 values, and it is a 3 by 3 determinant. So how many cofactors will be there? Obviously, as there are 9 elements, there will be 9 cofactors, every element having their cofactors, and it is defined as Cij equal to minus 1 power I plus j into Mij. See here, what is Mij? It is the minor, that is, after finding minors you can easily find the cofactors. So these are nothing but the minors. Now what to do with this? Minus 1 power I plus j. Earlier I just simply told that these are the sign of the positions of a 3 by 3 determinant. Now from here you see how these signs came. What is the formula? Minus 1 power I plus j. I means our I indicates the position of row, j indicates the position of column. For example, say this position. Here, what is the element? It is Aij equal to A13. So what is I equal to 1, j equal to 3. So what will be minus 1 power I plus j? It will be minus 1 power 1 plus 3 equal to minus 1 power 4. Minus 1 power odd is plus, even plus 1. So see, position of the sign is plus. Now see another one, say this one, this position A32. So here I equal to 3, j equal to 2. So what will be minus 1 power I plus j? It will be minus 1 power I plus j, 3 plus 2 5, minus 1 power odd minus 1. See this position, this is minus. So this is the rule how the signs are defined, and this is the definition of cofactors. Cofactors of the each element, that is position of the respective sign, sign of the respective position into their corresponding minors is the cofactor. So as these positions are positive, for these 5 positions, cofactors of these elements will be as same as the minor. Clear? How many positions are there? There are 5 positions having their signs positive. So for these 5 elements, for these 5 positions, that is for these 5 elements, their minors and their cofactors are same. So first find the minors, then for these 5 positions their cofactors are exactly same as their minors. Now see, for these 4 positions their sign is negative. For these negative signs, what will be the cofactors of the elements? For these 4 elements, their cofactors will be of opposite sign of their corresponding or respective minors. So for example, if this element's minor is 5, then its cofactor will be minus 5. I am coming with an example. So this is the minors and cofactors. This is the definition of cofactors, that is from the rule of sign whose signs are positive, their minors and cofactors are same, and whose signs are negative, their cofactors are opposite sign of their minors. And what is the process of finding minors? Finding minors is for example, if you are finding minor of Aij from a 3 by 3 determinant, then what to do? You have to delete that ith row and jth column from the given determinant. Then what remains? Then you will get a 2 by 2 determinant forming with the remaining elements. The value of that 2 by 2 determinant is the minor. Now let us see with an example, numerical example. Say the question is, find minors and cofactors of a 3 by 3 determinant. As an example, let us take del equal to, so I am taking a numerical, 2 minus 1 3 0 3 minus 4, say 2 5 1. This is the given determinant. Now every time you must use this notation. For example, to denote minor of 2, you use M11, because see here 3 is there, 3 is there. So if you write say minor of minor of 3 for this element. Again you have to write minor of 3 for this element, so there will be a confusion which 3 is indicating here. So the better technique is you always write M11, M12, M13 and dot dot M33. That is the always use the general form. Now let us find one by one. Say, okay, let Mij be the, you always write this statement, be the minor of Aij in del and obviously I comma j equal to 1 to 3. Now how many minors are there? As there are total 9 elements, there will be 9 minors. The first one is M11. M11 is which position? I am writing here the first one, minor of A11. Minor of A11. A11 means this position. 1 1 1 2 1 3. So M11 means minor of A11. So now see this element lies in first row, first column. You delete these one row and column. You delete first row and first column, then what remains? These 4 elements. 3 minus 4 5 1. And what will be value of this? It will be 3 into 3, this into this, minus 20, minus 20. So what is the value? 3 plus 20, 23. Now say, so what was the value? 23. Now say we are finding M12. M12 is this position, this one. Now we are finding minor of this one. Now see this one lies in first row and second column. First row, second column. Then which elements remains? These 4. So what will be the value? 0 minus 4 2 1. 0 minus 4 2 1. Expanding by expanding this into the 0, minus plus 4 8 equal to 8. So value of M12 is 8. Next let us find M13. First row, third column. First row, third column. That is, now we are finding minor of this element. So see the position, this element lies in first row and third column. What remains? These 4. So this will be 0 3 2 5. What will be the value? This into this, 0 minus 3 into 2 6. It is minus 6. So now I am just writing the value. It is minus 6. Similarly, the next element is this one, M21. That is first second row, first column. Second row, first column. We have to delete this. First column, second row, first column. So what remains? These 4 elements. This will be, see here, this into this, minus 1, minus this into this, 15, it is minus 16. So simply write the value, it is minus 16. Similarly, M22 means the middle element. This one, first row, second column. What remains? These 4 elements. So what will be the value? 2 into 2 minus 6. It will be minus 4. M23. M23 is this element. It is lies in second row, third column. So what remains? These 4. 2 minus 1, 2 5. What will be the value? 2 5s are 10. 10 minus 2 into minus 1. So it will be plus 10 plus 2, 12, etc. I am not showing the last 3. In the similar way, you can find the last 3 element also. It is minus 4, 1, 3. So these are the minors of 6 elements. Rest 3 minors you can find in the similar way. Now these are minors. Now let us see which are the cofactors. These are minors. Now these are cofactors. So what was the definition of cofactors? Cofactors are absolute value. If you consider the absolute value, then absolute value of cofactors and minors are same. The only difference is for the diagonal elements. These are the plus minus plus minus plus minus plus minus plus. That is, for these elements minors and cofactors are same, and for the rest 4 elements cofactors are opposite sign of their minors. Now say M11, what is the position? This one, it is plus, so its cofactor will be same as its minor. Now C12, which position? C12 is this position. The position of the sign is minus, so its minor is 8, so its cofactor will be of minus 8. Then M13, whose position? M13 is the third position of first row, it is plus, so its minors and cofactors having same value, that is no change. Now see C21, that is cofactor of the element A21 whose position? Which position? This one is minus, as its minor is minus 16, so its cofactor will be 16. M22, this is the middle position, it is positive, so its minor and cofactor will be same. Sorry, it is C22, this is C13. Now last one, C23, cofactor of 2, 3, this element, it is minus, as it is minor is 2, so its cofactor will be minus 12, etc. Similarly you can find the cofactors of the rest of the 3 elements. So this is the process how to find minors and cofactors. So these are clear. Now see the last one, how to find value of a determinant using cofactors. This is the very simple one. Here I am just showing the general formula. Let us take del equal to the general form A11, A12, A13, A21, A22, A23, A31, A32, A33. Also let Cij be the cofactor of Aij in del, obviously I, j 1 to 3. Now, as I have discussed in my previous videos how to expand or how to find the value of a 3×3 determinant, there are total 6 ways. Here also using cofactors there are also 6 ways. Now see how using cofactors, what will be the value of the determinant. Say I am expanding this determinant by first row. So using cofactors, now see it is assumed that Cij is the cofactor of Aij, that is, what is the cofactor of A11? It is C11. In this case the value of the determinant will be in any row or in any column the element and its cofactor plus the element and its cofactor plus this element into its cofactor. Or now if we expand this by second row, then what will be the value? It will be A21 into C21, that is the element into its cofactor, plus A22 into C22, that is the second element into its cofactor, plus third element A23 into its cofactor. Similarly you can use the third row also. Now say I am expanding this by first column, or you want to expand this by the first column. In the similar way, what will be the value? It will be A11 into C11, the first element into its cofactor, plus second element A21 into its cofactor, plus A31 into C31, that is its cofactor, etc. 3 more ways, third row, second column, third column, exactly in the similar way. So this is another way of expansion of a determinant of order 3×3. So up to this I have discussed three methods to expand the a 3 by 3 determinant or to find the value of a 3 by 3 determinants. The minus method or Laplace expansion method, minus method, and this cofactors method. Nothing different or distinct, because cofactors are defined by their minors only, and Laplace expansion is also this one only. That is, using cofactors we can represent Laplace expansion method in a different way, and the shortcut method or the search method is another way in which you can easily find the value of a determinant of order 3. So up to this we have discussed what is minors, what is cofactors, how to find cofactors just by using their minors and the rule of sign, and the last one, how to find the value of a determinant by using their cofactors. This concept is actually very important for MCQ type questions also. Using this relation, different questions can be formed. So hope these things are clear. In my next video I will discuss adjoint or inverse of a determinant, and another thing, these concepts minors and cofactors are very important for matrix also. There are important very uses of these minors and cofactors in matrix. So hope these are clear. If this was very helpful, please subscribe my channel and don't forget to press the bell icon to get notification of my further videos. Thank you.